All right, welcome back here, Algebra 1 students. We are going to talk about the second segment of 8.5 and 8.6 here, and we're going to be focusing our attention on exponential models, okay? So I'm wondering if you know the applications of exponential models. So what we might use exponential models for in real life. And there's some examples down here. So let's just go through some of these. So we will often use exponential growth or decay models to model the value of cars, okay? So cars, when you buy a car, they typically go down in value when you buy a brand new car. And at some certain point in time, I suppose that car might slowly start going up in value, but that's normally just the case for very, very old cars. Okay? Typically, homes will go up in value. So they will be modeled by exponential growth functions. We also use exponential models to model finances. So maybe the amount of money in our savings account will go up with interest over time, or the money in our retirement account will hopefully go up with interest over time so that we have a lot more money when we're ready to stop working. And say, for instance, credit cards. If you have a big balance on your credit card, that balance could grow even more with interest. So normally all of those are going to be exponential growth. And then also we can model, say for instance, the population by exponential growth or even decay. Funny enough, some populations are actually decreasing instead of growing. So in our exponential growth model, we're going to look at that first here. We are going to use this equation right here. Y is equal to A times the quantity of 1 plus R raised to the t power, okay? Now, A is going to represent our initial amount. Okay? And then R is going to represent the growth or decay rate. It's the rate, whether it's growth or decay, and that's normally going to be a percentage, okay? So you want to make sure that you change that percentage into a decimal when you plug that into your equation. And then T is going to represent time. So over time, will my money grow or will it decay in my savings account? So let's go ahead and look at example number 1. And I want you to make sure you have your calculator handy because we're going to be plugging in some of these numbers into our calculator. So what we have here is it says you put $1,500 in a savings account that earns 4% annual interest compounded yearly. How much is expected to be in your savings account after 5 years? Okay, so we're going to just label everything. So this is our initial amount. So this is A, okay? The 4% is our rate. Oh, I kind of covered up the 5 there. So the 4% is our rate, R, and then we're going to have that money in a savings account. We want to know how much we'll have after 5 years. So 5 is going to be T, okay? So we're going to use this equation. Y is equal to A times the quantity of 1 plus R raised to the t power. And we're going to plug in A, R, and T. So Y equals 1,500 times 1 plus, now 4%, let's just talk about this for a second. 4%, I want to move my decimal place, 2 to the left, so that is the same thing as 0.04. So I'm going to plug that in as 1 plus 0.04 and then raised to the 5th power. Okay? So what you want to do next is you want to do the parentheses first. So we're going to follow order of operations, parentheses, then exponents, then multiplying. So let's go ahead and rewrite 1500 times 1.04 raised to the 5th power. Okay? Now I want you to grab your calculator and I want you to go ahead and raise 1.4 to the 5th power. Okay, so let's see here, 1.04 raised to the 5th power, and you should get, let's see here, 1.217, we'll say, okay? And then we're going to multiply that by 1500. So that's going to give us then a grand total of 1,824.98. Okay? So if I have $1,500 in my savings account and I leave it in there for 5 years, what will happen is I will have $1,824.98. Okay? So that means that I'm going to get $325 approximately just for letting the bank borrow my money. Pretty cool. Now, how would the equation change here if we leave that money in the savings account for 20 years? Okay, so we still have the same interest rate. So for part B here, instead of leaving it in for 5 years, how much will we have if we let the bank borrow our money for 20 years? So what we'll do is we'll take 1.04 and we will raise it to the 20th power, and that's going to give us 1,500 times 2.19, and then we'll multiply that by 1,500, and that's going to give us then 3,286.68. Okay, so that means that we will get, after 20 years, we will get $3,286.68. Okay, so that's almost double our money. That's actually more than double our money. We will get for free, we will get $1,786 approximately just for letting the bank borrow our money for 20 years. Okay, pretty cool. So let's look at example 2 here. It says you buy a house for $200,000 and it appreciates in value by 3% each year. What would be the value of the house in 7 years? Okay, so we're going to use that exponential growth model, y equals a times 1 plus r to the t. Okay, what is a, what's r, what's t? So a is our initial amount, right? So this is how much our house is worth now. So that's going to be a, our initial amount. Our interest rate is 3%, so that is R, and we want to know how much is our house going to be worth after 7 years. So we have T there. So let's plug everything in. Y is equal to 200,000 times 1 plus, let's see, 3% as a decimal is going to be 0.03. Okay, so 1 plus 0.03 raised to the 7th power. Combine your parentheses there, so we have 200,000 times 1.03 to the 7th power, okay? And then now what we're going to do is we're going to take our calculator and we're going to take 1.03 and raise it to the 7th power. And what you should get there is you should get 200,000 times the quantity 1.2, we'll just say 230, okay? All right, so now we're going to multiply those two numbers together, and what you should end up here is you should end up with $245,974.77. Okay? So your house, after 7 years of owning your house, you bought your house for $200,000, and after 7 years of owning that house, now your house is worth $245,000, and that means you could turn around and sell your house and make a profit of about $45,000 if you own it for just 7 years. Okay? All right, let's go ahead and flip over the back side here, and we're going to look at some exponential decay models. Okay? So exponential decay is very similar to exponential growth, but there's a subtraction sign. That's how we know the difference between growth and decay models. So A is still our initial amount, R is still our rate, and T is still time. Okay? So let's look at example 3. It says you purchase a vehicle. Every year the vehicle depreciates. Depreciates means it goes down in value by 9%. How much will the car be worth in 3 years? Okay, so we're going to use our exponential decay model. So y equals a times 1 minus r to the t. Now, our initial amount is going to be 35,000. Our interest rate is going to be 9%, and we want to know how much will the car be worth after 3 years. So time is going to be 3. So we're going to plug in, we're going to have y equals 35,000 times 1 minus, what is 9% as a decimal? That's 0.09. So 1 minus 0.09 raised to the third power. Okay? Evaluate your parentheses. So 35,000 times 1 minus, oh, excuse me, I'm actually supposed to be doing 1 minus 0.9. How much is 1, or oops, I forgot a 0 there. Let me scoot back here a tiny bit. Let's see here. I need to insert a 0 right here for my rate. Okay? So 1 minus 0.09 is going to be 0.91 to the third power. Now we're going to grab our calculators and we're going to take 0.91 and raise it to the third power. So that should give you 35,000 times 0.7535. Okay? And then we'll multiply by 35,000. And what that's going to give us is that's going to give us now a total of 26,374.99. Okay? So what's crazy about cars is they are one of those things that really doesn't hold its value well. And what's crazy is this $35,000 car, just after 3 years of owning it, has dropped in value about $86,000. So if you've lost, just from owning this car for 3 years, you've lost $8,600. Okay? So cars are not a good investment. Let's look at example 4 here. So for example 4, it says you purchase a cell phone for $980, okay? And it says that the value of the cell phone decreases 20% annually, okay? So what would be the value of the phone in 6 months? So what we're going to do here is we are going to use our exponential growth model, or excuse me, decay. Let's see, y is equal to a times 1 minus r to the t power. And let's figure out what the value of a, r, and t will be so that we know what we're inputting into our formula here. So let's see here. Our initial value of our cell phone is $980. Okay, that's a lot of money just for a cell phone. And it's going to decrease, that's why we're using exponential growth, it's going to decrease in value by 20%. So that's going to be our rate, okay? So 20% is going to be R. So here's A, we have R. And then 6 is going to be T. Whoops, I want to put a T there. So 6 is going to be T. We want to just know after 6 months. Now, what we need to keep in mind here is that, let's go back to this definition up here. So actually, we didn't really write it down, but time for exponential growth, time is going to be calculated in years. So maybe we should add that to our definition. So this should be calculated in years, time in years. So that kind of makes a big difference in example 4, and that's because we're looking at, what's going to be the value of this cell phone after 6 months. So how many years is 6 months? That's going to be 1/2 of a year, or 0.5, okay? So we're going to plug all these in, and let's see what we get. Let's see, A equals 980 is how much our cell phone was worth initially, times 1 minus 20% as a decimal is going to be 0.2, so 1 minus 0.2 raised to the 1/2 power, or you could say 0.5, okay? Let's go ahead and evaluate the parentheses there. So we're going to say 980 times 0.5, or excuse me, whoops, not 0.5. Let's see, 1 minus 0.2 is 0.8, and then we're going to raise it to the 0.5 power, okay? So grab your calculator. I want you to punch in 0.8 raised to the 0.5 power. And what you should get is you should get 980 times 0.894. Okay, so 980 times 0.894. Now we're going to grab our calculators and we're going to multiply those two numbers together. 980 times 0.894, and that's going to give us a grand total of 876.54. So just after 6 months, what has happened here is our cell phone has decreased in value by approximately $100. Pretty crazy. Just after a half of a year of owning my brand new cell phone that cost me almost $1,000, $980, it's now worth $100 less, okay? Now let's just briefly discuss the difference between exponential growth and exponential decay, okay? So let's write down the formulas here. Let's see, y equals a times 1 plus r to the t is exponential growth, and then y equals a times 1 minus r raised to the t. So the difference between the formulas is addition if it's growth, we're growing, we're getting bigger, we're going to add, or subtraction for decay, okay? So if we're growing, that means we're increasing, versus if we are decaying, that means that we are decreasing. Okay? If we're talking about money, we are talking about terms like we are actually earning. We're going to earn money versus decaying. That means we'll lose money. We will lose money. And if we're talking about, say, the value of something, like, say, a house or the value of a car, if something is going up in value, like a home is going up in value, we say it appreciates. It appreciates, it goes up in value. Or the antonym for that would be it depreciates. It goes down in value. So it goes down in value. Okay? So those are just some words to watch out for when you are solving problems that have to do with exponential growth or decay. Those are some key terms that will help you to decipher whether you should use the growth model or the decay model. Okay? So we are wrapping up Unit 7, and I want you to go ahead and get started on your homework for 8.5 and 8.6 Part B. And what we're going to do next is we are going to start our practice test here soon, and that is the next video. We're going to talk about the practice test, and we're going to be reviewing the problems that are going to be coming up on the upcoming test, which is Unit 7 test. Now, I want to remind you that there is a study session happening, and that's going to be at lunch. And you are more than welcome to attend. I encourage you to attend the study session. It will mean that you get 2 points of extra credit on your Unit 7 test. So keep that in mind. Also, if you need help with your math, I encourage you to go to the math tutorial lab in F107. And other than that, keep working hard. Make sure that you are practicing and doing your homework, and we will see you for the next video. I hope you have a fantastic day. See you next time.